Welcome to this video. My name is Darshan M.Katgeri. I'm working with Jain College of Engineering, Belgaum. In this video, I will be solving a simple problem on projection of solids. In that, we are going to solve a problem on square pyramid. So first, let us see how a square pyramid is. So a square pyramid typically looks somewhat like this. Its base is a square. So you can see that it is a square and it has four slant edges. You can see this is say the first slant edge, the second one, third and fourth. And it has four triangular faces, 1, 2, 3 and 4. And the edges of the base, these are the edges of the base, and also it has an axis, so we can see that it has an axis. In the problem, it is given that the edges of the base are 35 mm and the axis length is 60 mm and it is resting on one of its slant triangular faces. This is important. It is resting on slant triangular faces. Draw the projections of the pyramid when the axis appears. This is also important. It's told that the axis appears to be inclined to VP at 45 degrees. Let us see how to approach this problem. The first step in all the problems is to draw the XY line, mark VP and HP. Next, draw a square whose side length is 35 millimeters and name it accordingly as A, B, C, D. Next, join the corners AC and BD. These represent the slant edges of the square pyramid, and wherever the diagonals AC and BD intersect, that point is O1 and O2. O1 is the apex and O2 is the point on the base. This is point O1 and this is O2. Observe that it was put in the bracket. That is because it cannot be seen in the top view. Only this apex can be seen and the point O2 is below this, so it cannot be seen, so it is put in the bracket. So this is the view that is drawn, the square, and we have joined the slant edges to the apex. Let us try to draw the front view. The front view would typically look like this. We have to go to the presentation for this. Yes, take the projectors from all the points as shown here. Then you draw the axis. The length of the axis is 60 mm and join the points. Join the point A dash D dash to point O1 dash and B dash D dash to point O1 dash. These 2 points here, they represent the edges AD and BC. So this is the initial view. This is how you start the problem. The next step is you have to make this square pyramid inclined such that it is resting on one of its triangular face. Now in this case, we are going to rotate it like this, that is clockwise, and we have to rotate it until it rests on one of its triangular face, that is this blue color face, which is seen here. So now you can see that this square pyramid is resting on one of its triangular faces. Let us see how it appears in the front view. To draw this view, you have to merely reconstruct the view, which I will be showing you in the presentation. So this is how the view looks in the front view. and in the top view this is how it appears. If I switch on this mode, X-ray mode, you can see that the boundary edges, they are always visible, and this edge is the farthest edge. This edge is the farthest edge. So let me just zoom out and show. If you see from here, if the observer is here, with respect to the observer, this edge is the farthest edge. So whatever is going to start from this edge, except for the boundary lines, they are going to be hidden lines. Okay? I'll just clarify that here. Yes, this is the view. You have to just reconstruct the view here. Uh, I insist that you first draw the line B dash, C dash and O1 dash. You mark the point B dash, C dash here, and you measure this line and mark an arc here. Then you measure B dash, C dash and A dash, D dash, and from this point you mark another arc and measure A dash, D dash and O1 dash, and you mark the third arc. So wherever you have the arcs, you join the points and name accordingly. Next, you draw the projections. Take all the horizontal projectors and the vertical projectors. Wherever they intersect, name the points. Here be careful. Point A is here. Okay? So point A from here and point A from here have intersected here. So this is point A. Okay? And B, C and D. So name it accordingly and join the boundary lines. Join the boundary lines. That is BA, A01, O1D, DC and CB. So this forms the boundary. So join the boundary lines. The next step is to find out the visible and the hidden faces. That is the most important thing here. So how to do that? Let us come back to this visualization and see the observer is here. With respect to the observer, this edge is the nearest edge. So whatever is starting from this edge will be visible to the observer, as you can see in this view. Whatever is starting from this edge, that is visible to the observer. So we have a triangular face and we have the base completely visible in this case. So the base is completely visible and the triangular face is also completely visible. Next step is to spot the hidden faces. You observe that this face here, that is the farthest one. BC is the farthest one. So whatever is starting from this edge, except for the boundary lines, is not visible to the observer. So if I switch on this mode, you can see it more clearly that there are faces which are not visible. Okay, so this face here and this face here and the face on which it is resting is not visible to the observer. So to determine the slant edges that are not visible and the faces that are not visible, one thing that you can do is to spot the farthest edge. In this case, boundary lines are always visible. We must always remember that. So the first step you start is you join the boundary lines. Next you spot the farthest edge, as in this problem, and these lines which are starting from the farthest edge, that is BO1 and CO1, they are not going to be visible. AD is visible because it is the nearest edge to the observer. So whatever is starting from this edge is visible to the observer. So this is important. The next step is to get the final views. The next step is to get the final views, and in this problem it is given that the axis appears at 45 degrees to VP. So this word appears is very important. Okay. Appears means that the apparent inclination is given to us and the view available to us is the apparent view. So apparent view is available, so we have to go for locus method. We have to go for direct method. So because both are apparent. So in the third step, the axis is inclined to VP at some inclination. That is, in this case, it is 45 degrees. So we have to draw a line at 45 degrees with respect to the vertical plane. So we can see that in the top view. You can see that this line is inclined at 45 degrees to the vertical plane, to this particular plane. Yes. Let us see the top view once again. You can see that there is no change in the top view, the appearance of the top view. Only thing is that in this view, the axis is parallel to VP, which has to be made at 45 degrees to VP. So it is made at 45 degrees to VP. Apparent inclination is given and apparent length is available. So we have used direct method to solve this problem. So you have to reconstruct this particular view here. So we have to draw a line at 45 degrees and we have to reconstruct this view here. So to reconstruct, I insist that you mark one point O1 here, O1 here, and O2, O2, and with respect to these 2 points, you can measure all other points and get the intersections and join the intersections respectively. So it is going to look something like this. So you can see that there is absolutely no change except for the axis inclination at 45 degrees. There is no change in the hidden lines or the visible faces of this particular solid. It is only made inclined to VP at 45 degrees. Next is the final step to get the final front view. We have to take all the projectors from all the points. So the vertical projectors and the horizontal projectors, wherever they meet, the intersection of those two projectors will be the location of the points. So one by one, take all the points from B here and from B here. This will of course lie on the XY line. C from here, C from here, D from here and D from here, and take all the projectors and join the boundary lines. Join the boundary lines. The first step is join the boundary lines. Boundary lines are always visible. Okay, so these 3 points are lying in a straight line. So you join these lines and you join the boundary lines. Next, to determine the hidden surfaces, we will go to the front view here. See that this is the farthest in the top view. See that this is the farthest point. So whatever is going to start from this particular point, except for the boundary lines are always visible. Whatever is going to start from this particular point, that is the farthest point of the base, will be hidden. So you can see that this is the farthest point, that is point A dash here. Whatever is going to start from this point, what all is going to start from this point? There are 3 lines starting from point A, that is AB, AO1 and AD. So AD and AB, they are already drawn. The only line that is remaining is AO1. So, and this line is going to be hidden because it is starting from the farthest point. Also, you can visualize that this line is basically lying behind the axis And yeah, it is very clear in this particular view. You can see here, this line is behind the axis, so this line will not be visible. Let us come back to the presentation. So this is the complete solution to the given problem. This is the initial view. This is the apparent view, and this is the final view. This problem can be solved in the grid sheets which have been already uploaded in the group. Thank you.